Coach Hero here with RC Culture, and today we're going to talk about anodizing, or actually removing anodizing. So we should talk about what anodizing is first so we know what we're talking about. Anodizing is an electrochemical process that converts the top layer of metals like aluminum to an anodic oxide finish. It's a fancy way of saying rust, but in this case the rust is aluminum oxide, and it's chemically bonded at the atomic level to the aluminum itself. So you can't chip the finish, you can't peel the finish off like you could with a paint, and it takes a pretty strong chemical to remove it. The chemical we're going to be using today is caustic soda, and it can be found in a lot of different household chemicals. We're going to be using it from a drain cleaner, but you can also find it in oven cleaners. What we have here are a Tamiya shock from a touring car series, and two pieces that are just a standoff for a sway bar mount. Now if we look carefully at these, we'll notice that on the end here, this end, the anodizing finish is actually a little bit lighter color than the pieces on this end here. And that can happen when anodizing aluminums in different batches. So if the end piece wasn't done in the same batch as the top piece, then you can wind up with slightly different colors. And that's a fairly common thing. What we're going to be doing here is removing all of that color and winding up with a silver finish. So the first thing that we're going to do is take a little bit of string, and we're going to run that string through these pieces here. And they have a number of different holes on them, as you can see. So I'm going to run that string through them and just create a loop so I have something to hang on to, because we don't want to get the caustic soda on our skin. So I'm going to do that, and then we'll be right back. Okay, so here you can see I've got a little bit of string for each one of these pieces. It's not long, just maybe a few inches per piece. You can see here. We're going to put our caustic soda solution into a bowl of warm water. It doesn't have to be a deep bowl, just enough to get your part into. So the string just has to be long enough so that you don't get your fingers into that solution. It's very toxic and can irritate your skin quite a bit, so we don't even want to touch it. Let's check out the tools that we're going to be using here to do this. First off, I've got everything sitting inside of my stainless steel sink. Here, first off, we have a toothbrush. We're just going to use this to brush off the excess caustic soda solution. We have a glass bowl. This is for the caustic soda solution to sit in. We don't want this to be splashing all over the place. We don't want to use a plastic bowl because the caustic soda can actually eat the plastic. And finally we have, in this case, Mr. Muscle, which is a drain cleaner, but it contains caustic soda. Now you want to be doing this in a very well ventilated area because caustic soda smells really, really strongly. It's not good for you. If you have a mask, I would highly recommend wearing it. So let's go ahead and start the process. First, we're going to put a small amount of very warm water in our bowl. About half the bowl, or basically just enough to cover your part. And then we're going to take a very small amount of caustic soda. Not much is needed here, basically about half a spoonful. We're going to put that in. And then we're going to stir it a little bit with our toothbrush. This just sort of gets it all dissolved, or at least partially dissolved, and you can see the solution starts to turn sort of a milky white. Okay. Eventually, as everything gets all mixed in, it will start to clear up. And in the meantime, we're going to prep some cold water, because that's how we're going to neutralize the caustic soda chemical reaction that's taking place with our aluminum. And it's very important that we do that. Otherwise, the caustic soda solution can actually keep eating away at the aluminum, and eventually, over a long period of time, your part would probably disappear if you left it in this solution long enough. All it's going to take is a few seconds to do this. What we're going to see happen first is it will start to bubble. We're going to swirl our part around in there, and when it starts to really bubble, it's going to look a lot like what you see on TV when somebody dips something into acid, for example, because this is really just a form of an acid. So here we go. Now I've done this as a very light mixture so that we can really see this happen. But right now you're starting to see some of the bubbles form as I swirl this around. You may be seeing the color of the water turn a little bit purplish, and we're starting to see the metal turn a little bit black actually in areas, and that's part of the oxidization happening on the surface. So it's been a few seconds. I'm going to take this out, run it under cold water, and at the same time brush it a little bit with our toothbrush. Now if we take a look at this, although we can see this on camera, in some of the grooves here we still have a little bit of the red coloring. So I'm going to put this back in for a few more seconds. Out, so I'm out of the cold water. So here we have our raw aluminum part, and I know it's not shiny like you might have been expecting to see, but that's not a problem. We're going to polish it up in just a little bit. So let's move on to the next part. Now, as I said, I've done this as a very, very light mixture so that you can see what's happening. You can, of course, put more caustic soda in. Things will start to happen much, much faster. I wouldn't recommend doing that until you've really kind of gotten a feel for doing this and knowing what it's going to look like, knowing how much it's going to smell, actually. It's quite strong. Okay, and we'll rinse this one. Here we can see this part came out quite a bit brighter, quite a bit shinier than the other. I'm not sure of the exact reason for that. I think it does have a lot to do with the anodizing process and perhaps even the quality of the aluminum, as well as just your timing with the caustic soda mixture. On to the next one. If you are doing larger parts, like say a shock tower, perhaps even an entire aluminum chassis for some larger scale vehicles or some nitro vehicles, obviously you'll need a larger container, but you'll probably also need a much larger concentration of the caustic soda to handle those larger pieces. As you do more and more pieces, the caustic soda will get sort of used up, so you will need to add some more, and I'm going to do that here after we finish this piece. Okay, so here we have a fresh mixture of caustic soda. Swirl it just a little bit to start the chemical reaction happening, and in goes our part.
See, right away we're getting a lot of color. This is a stronger mixture, just so you can see the difference in the timing. And you can see even the part sort of smoking here. That means that there's a lot of stuff going on there. That's why we need our cold water to neutralize that reaction. And we brush it just to get rid of some of the excess oxidization that's occurring, so we don't have quite so much polishing to do. And of course to make sure that we're getting rid of any of the excess caustic soda. And on to the next one. Sometimes you can even hear it sizzling. Like I said, this stuff is very, very toxic. On to the next part. Now, as I said, this stuff is very, very toxic. You don't want to breathe it, and you don't want to touch it. However, as soon as you've got it going into the cold water, it almost immediately neutralizes the reaction, so it's okay to touch it. And our last part. Now in our case, because we're using a drain cleaner, we can actually just rinse this right down the drain. We don't have any special cleanup procedures involved like you might with an oven cleaner, for example. So all we need to do is turn on some cold water. Let that run down the drain a little bit. And then we can slowly pour our mixture down the drain. Okay, so here are our finished pieces. This is just raw aluminum in its various states, and if you look really carefully, you will probably see a little bit of red anodizing still left here and there, like in the threads, for example, where the screws thread in. But this is okay. You'll never see this when your piece is assembled, and you may actually remove some of it during the polishing phase.
Okay, so we've removed the red anodized finish, and we now have a batch of raw aluminum pieces. The next thing that we want to do is to actually polish those pieces. So we're going to do that with our rotary tool, Dremel tool or other name brand variant of it, with one of those white polishing wheels and a little bit of plastic polishing compound. So let's head into the studio and we'll do that.
Okay, so here are the tools that we're going to be using to do our polishing. First up, I'm going to be using my corded Dremel 4000. And then for our polishing compound, we're going to be using a Sonox brand plastic scratch remover. From what I found, this is about a 5,000 grit equivalent if you were to actually be using sandpaper. And then finally what we're going to be using are some Dremel polishing discs. And these are just the plain white fabric-based pads that come in just about every Dremel kit for polishing. And here you can see one that I've been using previously with the plastic polish, and it's just got some of the oxide residue on it. Okay, so I've put our bit into my Dremel tool, and we're just going to take a tiny little bit of our plastic polish. We don't need very much at all, just a little bit of a dab. We'll set that aside, and we just want to take this and sort of run it around with our finger, because what's going to happen when you turn this on, because the Dremel tool runs at several thousand RPM, is a lot of this will spit off if you just have one major clump, and even with doing this, a lot of it may come right off. We're going to start off with our shock cap, and we're going to start polishing this up. And basically all we want to do is set our Dremel tool to a very low speed. In this case I'm using about 5,000 RPM. We're going to turn it on and just run the polishing bit over the surface, and we should see an immediate improvement in how shiny it gets. So let's go ahead and do that. Okay, so you can see that there's quite a bit of black residue on my fingers, and we've got a fair amount of residue here. So we've got an old rag here, and we're just going to wipe this off and see how it looks. Polishing is not a hard thing to do at this level. We're just taking off the top layer of oxidation. You don't need to press hard, you don't need to bear down on it, you just need to put some light pressure and run over the whole surface. The polishing compound, the scratch remover, is actually doing all the work because it has, like I said, a 5,000 grit to it, which is just enough to take off that top little bit of rust and oxidation that we've seen. So now if we take a look at our part, we can see that it's quite a bit shinier than it was. You can see we're getting some decent reflections here now. And if we wanted to, we could keep going with the polishing. But for right now, I think this is fine for what my purposes are on this one. You're not going to get a lot of shine at it. I mean, it's not going to turn into chrome. This is really probably about as good as you're going to get in a lot of cases, because aluminum, just doesn't get super shiny. If we were making like a piece of jewelry, for example, then what we would wind up doing is putting this like in a rock tumbler. And we get a whole different level of shine from there. We could go into further compounds that are even finer than 5,000 grit and get a little bit more shine out of it. But again, it's never going to come out like a chrome finish. And so there you have it. I'm going to go ahead and polish up the rest of our pieces, and we'll reassemble our shock and see how everything looks. Okay, so here we can see that we're starting to finally run out of compound. And I did this on purpose to show you that you don't have to put on compound for every last little part that you're doing. You can start to tell when the compound that you have on here will go away because you won't see any of the residue coming up anymore on your part. You won't see the darkened black areas that kind of wipe off on your fingers and those sorts of things as your compound starts to go away. And obviously you won't see any shiny polished areas either. So we just need to put a little more on. And we take our part again and pick up where we left off. And you can see immediately that the color lines on the spinning of the wheel change as they're picking up more of the oxide residue. Now we won't ever get fully into every one of these little nooks and crannies here, which is why it's important that we make sure we get all of the anodizing color off, because again, anodizing is not something that can be scratched off the surface or peeled off because it is chemically bonded to the surface at an atomic level. You can see here we still got a little bit of residue left. You can kind of see this angle mark right here. So we'll just take our Dremel again and polish that out. And if that doesn't quite get it, then we'll apply a little more compound, and that should take it out. So we need just a little bit more compound on our wheel because we're starting to go away enough to where we can't quite get that last scratch off. I say scratch, but it's in reality not an actual scratch. It's a line of oxidized residue. It's just easier to say scratch. Oh, should do it. Still see a little mark of it, but I think that may actually just be an imperfection in the metal itself. It could also be where we had some caustic soda stick a little bit too long and it's etched the surface of the aluminum. That can happen, and there's really not a lot you can do to get rid of it unless you want to go through the whole process again just to try to remove a little tiny area. In my opinion, I think it's a little bit too risky to do that, and it's really not worth not only the effort but the risk that you might damage the part further. This is a very, very inconspicuous flaw, so to speak. If you remember, our shock cap or top sits up through here like so. So you're really, really not going to notice that spot when you're looking at this piece casually. Remember, there's going to be a whole lot of other parts. We're going to have a screw running through here holding this whole thing in place. This is going to be sitting on top of a chassis. It's going to have a whole lot of other pieces and parts to look at as well. So one tiny little area we're really not going to see. And our last part. Okay, so let's get the rest of the pieces to our shock and we'll put the whole thing back together. So here we have the pieces of our shock laid out. I'm not putting any oil in at this time because this is actually just a spare shock, and I may use one particular oil at one time and another oil at another time depending on what I need it for. But we'll go ahead and reassemble it anyway. Now we could have also removed the anodizing from the shock body itself here, but as this is fairly close to raw aluminum looking, it's actually a dark gray anodizing. But I didn't find it necessary because in this case I think it's going to match fairly well with the polished aluminum look that we're going to have. Now these are a pair of flat pliers. They have no teeth on them, so you can grab things like shock shafts without putting too much of a mark in the smooth shaft itself. But even so, I still grab way down here at the very end, right next to the edge of the threads. That way this part of the shaft never actually moves up inside the body, so I don't have to worry about a mark or a cut or any kind of groove in the shaft allowing oil to seep out. I'll just spin this down a little bit more so we have just a slight amount of tension on the spring. So this is our final shock, fully assembled, no longer red on the upper eye, the cap, the adjuster ring, the lower cap, and the spring retaining ring. It's a very different look, and that's the primary reason why you would want to remove anodizing. There's a lot of other reasons. For example, if you're looking for a particular hop-up for your car or truck and it's only available in a certain color and that color doesn't happen to match the rest of the theme that you're going with, or it just doesn't go. For example, if you're running certain HPI cars, all of their anodizing is orange, and if you're looking for a different set of shocks, maybe they come in blue and you don't want orange and blue together, well, you now have the option of doing orange with raw shiny silver.
So there you have it. That's how you remove anodizing from aluminum. Again, we used caustic soda in a warm water solution in a glass bowl. We dipped our part in until we saw bubbles forming and saw the part turn black. We then removed the part, ran it underneath cold water to neutralize the reaction, and then to bring the shine back we used a rotary tool such as a Dremel tool with a polishing wheel and a plastic polishing compound. Now remember, caustic soda is toxic. I would recommend you wear a mask when you're doing this, and kids, please do not do this at home without adult supervision. This is Koichiro with RC Culture.